Thank you. Dr. Semper, Rob, Dr. Brand, Stewart, ladies and gentlemen, friends, colleagues. In Paul Gauguin's 1898 Tahitian masterpiece, which he intended to be his last work before he committed suicide, he gave the title in the upper left-hand corner as three famous questions. Where do we come from? What are we? Where are we going? These happen to be the central questions of religion and philosophy. Through millennia, we've thought and argued about the first two questions. Where do we come from and what are we? Will we ever be able to solve them? Sometimes it seems not. Yet, perhaps we can. Religion will never provide the answers. The reason that each organized religion, and there are hundreds of them, has its own different creation story in competition with all the others. Each creation story was written in times and circumstances when the authors knew almost nothing about the universe, the planet, life on Earth, and the prehistory of the human condition. And each considers its creation story in answer to where do we come from and what are we to be the correct one, and also set in stone and superior to all of the others. Each was born from the dreams and speculations of shamans and prophets. They cannot all be correct, though two can be correct. None, in fact, is consistent with our growing knowledge of the universe, the planet, life on Earth, or the prehistory of the human condition. We also look in vain at current academic philosophy for the answer to the great question, the great riddle. Despite its noble purpose and history, despite its effectiveness in training the mind to inquire and think logically, professional secular philosophy long ago gave up trying to answer the overall question, what is the meaning of life? Most of the history of philosophy is strewn with the wreckage of theories of the conscious mind. After the decline of logical positivism in the middle of the last century, and the attempt to join science and logic into a closed system, philosophers have scattered in an intellectual diaspora into those areas not yet colonized by science, intellectual history, mathematics, foundational mathematics, ethics, and most profitably, problems of personal adjustment. By default, then, the solution of the great riddle has been left to science, to knowledge of the real world that can be tested and shared with every person. What science promises, and has already supplied in part, is the following. There is a real creation story of humanity, and one only, and it is not a myth. It's being worked out and tested and enriched and strengthened step by step. What I'm going to attempt now is to tell you that story. It comes together from multiple disciplines, from molecular genetics and neuroscience and evolutionary biology to ecology and archaeology and psychology and all the way to history. And it has come from my own gleaning of the primary literature, especially of the last 20 years, from premier journals. And it is the piecing together like a jigsaw puzzle that I've been attempting, and not an idea that just sprang from my head. To make that effort, let me first define the very high level of social complexity called eusociology. Eu means, well, literally gentle, pleasant, but it also, we take it to mean true, the central condition. It is the existence of groups over multiple generations in which adult members rear the young collectively and vary longevity or reproduction of themselves or both in ways that enhance the complexity and success of the social system. There are countless thousands of animal species that form groups of different kinds, and some are dramatic, like the gorilla, but almost all of the gorillas and other animals fall short of eusociality. They lack a consistent division of reproduction and labor based upon altruistic behavior. I have before you now the two social conquerors of Earth. In fact, true eusociality has originated on the terrestrial part of the planet only very rarely. I count some 24 times throughout the history of life, of which we have record variously in several kinds of insects and crustaceans, twice in the mole rats of Africa, and then once in the human lion. It doesn't happen at all until quite late in evolutionary time, from the early Mesozoic, about 150 million years ago. When it did occur, then it produced species that dominate the environment. The ants and termites alone, even though there are approximately 15,000 known species, are only a tiny fraction of the 1 million known species of insects, make up, in most habitats of the world, as much as half of all of the biomass. They absolutely rule the invertebrate land and living environment. And humans, of course, are the dominant of dominance. So ants in most parts of the world weigh as much as 4 times all of the vertebrates put together, all of the land vertebrates, birds, amphibians, reptiles, mammals, as indicated in this little diagram showing the jaguar, and then the relative size of the biomass of all the ants found in the same locality, in this case in the Amazon. And finally and strikingly, it is this very small array of evolutionary lines that have been the most persistent through evolution. Once acquired, then the matter was settled as who was going to rule the world, so to speak, in terms of dominance and ecological impact on the rest of life. So, here then are the two important mysteries of evolutionary biology relevant to the origin of eusociality and hence of the condition, the human condition. These are two questions not asked heretofore, to my knowledge, by biologists or any scientists. It just didn't occur to them, apparently, ever to think that this is what we need to know first before we can explain where we came from and what we are. First, that eusociality being given that it's so successful, why is it so very rare, and why did it take so long to originate in evolution? And then the second great question, largely unanswered, but I'll be addressing it, is what is the force in evolution? What kind of selection pressure drove it? This is the setting we need to address in order to understand the origin of humanity. And these are the questions that biologists and anthropologists have not yet answered. It did take a long time. During the Paleozoic period, 400 to 250 million years ago, the coal forest of the earth teemed with insects of great variety. By that time, some of the major groups like the beetles, the mayflies, dragonflies, and cockroaches had appeared, and they were radiating into many species. They were very, very prominent. But there were many other groups of insects that went to extinction with the Permian crash 250 million years ago. And they included insects you never heard of, Paleodictyoptera, Proteolotroptera, and so on. Thus the first great covering of the world by insects yielded no eusociality that we are aware of. And vertebrate life, similarly very tardy. Throughout the Mesozoic, we had dinosaurs of great variety, many of which were bipedal and had free hands. And they had the capacity, no more, no less than some of the primates, to develop a larger brain. They never did. If they had, the dinosauroids of the Mesozoic, who took over the world instead of waiting for the mammals to do it, might have looked like the creature on the right. The first ants and termites appeared, but in the Mesozoic, and then slowly built up to a dominant position by the early part of the Cenozoic. Some 65 million years ago, they began to take over in big time. Now, this is the evolutionary maze. To explain what happened, or better, usually did not happen, let me offer the metaphor of the evolutionary maze. Species proceed through the maze step by step, led by action of natural selection, generation by generation, on the genomes they possess and the environments they occupy, each present instant of time. They are not moving in a particular direction because they are drawn in that direction or because there is any such thing to our knowledge of evolutionary progress. They are simply moving like particles at random in the surrounding forces, driven by the surrounding forces of natural selection. They can move in one direction and say we are now tracing the movement of solitary or very primitively social creatures from the upper left-hand corner all the way through the maze. And if they can come out, take the final step, they will be eusocial. Move in one direction or another, moment by moment. They can stall, they can even regress. It's a matter of luck to reach any point in that maze, and that is achieved by a series of particular steps, each of which may or may not take place. If we look retrospectively at the result in which we are interested, in this case, eusociality, then we can speak of the steps as pre-adaptations. There is a final step in the origin of eusociality, that event that has occurred, of which we have record some 24 times. The final step that takes it across the threshold from solitary or elementary group to eusociality. What is that final step? I'm going to show you. This is something I know people have not thought about. It turns out when you look at the evolutionary steps that have led up to most of these cases, all the ones we can track the evolution in, that final step, the final pre-adaptation that takes the species to the threshold in the evolutionary maze, is the building of a complicated nest, defensible, from which individuals, a female or a mated pair, or maybe a small, simple group, forage and pick up food that they bring home to feed the immatures until the immatures reach maturity. And in most cases where that occurs, then they all disperse and begin yet another cycle of individuals building a defended nest. But in a few cases, these rare cases, the young do not leave. They stay, and then we have a eusocial, a primitively eusocial society. In A, we see marine shrimp that actually build nests in sponges in shallow marine water. And on 5 occasions, it's known, independently, these type of synalpheus shrimp have evolved primitive eusociality. The queen is in the middle, the workers around her, and one of the workers is guarding the entrance to their nest. On the right, we have the sweat, on B, we have the sweat bees, halicted bees, that have built nests in the soil. And once again, when the young stay with the parent, then they, in one short step, it could be by a single mutation silencing the tendency to disperse. We have it created. So this must have happened many times before, because there are large numbers of species that have made it to that final threshold, but they do not cross it. Or if they cross it, then the species goes extinct. That mutant form becomes extinct. And why is that? It is because the group as a whole has to succeed in competition with solitary individuals and other groups of other kinds that are actually in opposition to it, in competition. And for reasons we have not yet investigated, but it's now wide open to do so, group selection has to be powerful in order to overcome the effects of individual level selection. Individual level selection has been working for tens to hundreds of million years in these evolutionary lines, and the species is in every way adapted to individual level selected traits to see it through a successful life cycle. So when the group is formed, it's something new in this manner. There has to be such a powerful advantage to that group staying together that it overcomes individual level selection. The beetles in C are an example of the wrong way to get to eusociality. Not that they're trying, but there are large numbers of these pre-social species of organisms, including a lot of beetles, in which, as in this case, the parent beetles herd the larvae along. They take care of them. They take them from one food source to another. And never, to our knowledge, does a migratory group of this, without the nest, without foraging away and bringing food to the larvae, never has led to eusociality. So this is a pretty strict requirement, pre-requirement, pre-adaptation to move on. Quite a few of the of species are at the threshold. Chimpanzees and gorillas, for example, are shown here, African wild dogs, but they have not taken the final step. So why they have not is a remaining evolutionary question of very considerable importance. Now I'm going to recent primary literature to trace the steps that have been worked out by many scientists, to trace the steps that the pre-humans took to create a eusocial human. In other words, went through the pre-adaptations that led from the split between the pre-human and chimpanzee lines some 6 million years ago. Now this is a synthesis, as I say, of a great deal of work, and I have based it carefully upon existing peer-reviewed reports in key journals. Here is the first step. Get out of the trees. The chimpanzees did this, and the idea is to become bipedal and free the hands. The chimpanzees are not really bipedal. They're quadrupedal. They still knuckle walk for most of their locomotion, but they can stand and walk on the hind legs, but they just didn't do it the right way. The chimps, nonetheless, as many of you know, that line with the two species, the chimpanzee and the bonobo, have achieved an awful lot of advanced behavior, including social behavior. They have cultures in which, from troop to troop or from region to region, from Senegal to Kenya or wherever, different groups have their own cultures that they've invented, throwing stones, or in this case, for example, using pieces of wood or the bones of animals to dig up tubers. But that's it. They haven't gone beyond that. This is the habitat in which the chimp lions lived all that time and in which the human lions live. And these are hunters, gatherer, bushmen who are showing the same appearance, physical appearance, we are fairly certain, and modes of life that the ancestors for all modern Homo sapiens in the world were following when the breakout from Africa occurred 60,000 years ago. And this is the habitat in which it occurred, the savanna and the grassland. Ardipithecus. We don't have much material on this creature that lived 4.4 million years ago, but here we had a completely bipedal, straight up walking primate. The only thing was that it was still had the brain size of a chimpanzee. This very likely is an ancestor of the human line going way back. Ardipithecus, or something very close to it, in time gave rise to a whole series of species that appeared, as many as 3 living in Africa at the same time, of the Australopithecines. They were erect, clearly, at least one was in line to create Homo later on. They were vegetarian. They were specialized for different types of vegetable food and ways of getting it, probably, and habitats in which they had occurred. So in the typical manner of an adaptive radiation, species multiplied and they filled different niches. Again, the Australopithecines underwent only a very slight increase in brain size from the chimp volume, 400 centimeters, maybe to 500 cubic centimeters. If, say, 3 million years ago, E.T. had landed and looked over the fauna of Earth, and it had seen the Australopithecines striding around on the African soil, eating fruit and communicating back by sounds with each other like chimps, they would have made no special note of it. But some 3 to 2 million years ago, a remarkable event happened, as illustrated here. The brain size, after remaining static for all that period of time, suddenly began to increase. And it went through a steep incline of increase, primarily in the forebrain. Unlike any other evolution in rate of a complex organ of which we know, and thus was created eventually the genus Homo. This is what happened starting 3 to 2 million years ago. What caused this sudden departure? One line of the Australopithecines began to eat more meat, started becoming more of a carnivore. We know that from bone structure, from changes in the skull, and it was pretty clear that they had changed their diet somewhat from a more purely carnivorous diet, from a purely vegetarian diet. Even today, chimps, if I've got these figures right, chimps get on average about 3% of their calories from meat, from scavenging and from hunting to some extent. They hunt vervet monkeys, gangs of males do. But the average consumption worldwide for humanity is closer to 1/3. And this is something of this nature had happened then in this period at about 2.5 million years ago. And it's here that we see the brain size sufficient, having increased substantially, and the bone structure of the face to place it in the genus Homo, no longer in the genus Australopithecus. And we can surmise, but have no direct proof, that by this time they were working out of campsites and bringing the prey and meat to the campsite and sharing it there. We can surmise that, but we don't know it for sure. We certainly know that it happened by the time Homo erectus, a direct descendant of the Havilines, had come into existence by 2 million years. We have direct evidence of campsites with controlled fire, not hard to do. All you've got to do is pick up burning branches from lightning-struck ground fires, which occur at frequent intervals through the African savanna. And of course, they would have also encountered animals killed by the fire, and partly or wholly cooked, so that it was easier to digest. And thus, the Homo skull crusher, our dentition, our gut began to change to feed on cooked food, including meat. Here is the nest. It's the campsite where we know they came and stayed for a long time. They went out from there, some went out, and they divided labor in that manner. "60,000 years ago, then, after substantial more evolution within Africa, leading to modern form of Homo sapiens, the breakout occurred from Africa, and that species quickly through the Nile corridor, and that breakout resulted in rapid spread across Asia and on across into New Guinea and beyond into Australia. As we see here illustrated, the first Australians. And this is the way we believe all of our ancestors looked 60,000 years ago. Something like this. They have evolved too, but we've evolved at least in skin color, as most Europeans have, and Asians in other ways. But I can say not in cognitive ability. It is demonstrably about the same. The signature behavior of the groups, of the newly evolved and spreading humans, was aggression between groups. And we think of the Yanomamo of northern South America, for example, as being unusually aggressive. But that has been true in intervals of virtually all human society, periods of extreme aggression. Right into history, as William James said, history is a bloodbath. The Mayans depicted their wars and genocides and sacrifice proudly. On the walls of the caves of Spain and France back to 32,000 years ago is a large amount of art that's not ordinarily displayed in the art of published of the Grotte Charvet and other of the classical cave art murals. There's a lot of graffiti, some of which would not be appropriate for hanging on your own wall. In addition, there is abundant evidence of killings of people, men primarily by spear. And this seems most likely to have been a depiction of raids, vengeance raids, territorial raids occurring frequently. Now, let me just remind you with a quick diagram of what individual level selection is. This would be the way it would look, say, in the change of bird color. If the environment were such that a dark blue for a particular bird, in this case it's an imaginary example, and there were a series of alleles or distinct genes that darkened or lightened the plumage color, in an environment in which the genes were competing and individuals were competing with their offspring in regaining resources, including nest sites and food and so on, then we would expect to see, generation by generation, the gradual shift of the genes in the population to those prescribing darker blue color. That's it, simple Darwinism. In contrast, the evolution by group selection, which is demonstrable, particularly in the social insects, where we have from group selection, which is going on all the time, ants and termites are the most warlike of all known creatures. Their colonies are always in conflict and war. One colony will destroy another neighboring colony if it is able to overcome them. The results of this, in part, has to be the amazing, spectacular display of casts of all kinds and the morphology, behavior, and the like. There is no other explanation, as Bert Holdobler and I have pointed out at length in our book, The Superorganism. It was occurring almost certainly in human beings as well. It was Darwin who, in The Origin of Species, embraced group selection, which in recent years has become disfavored. But he saw that this was how to explain the origin of the worker caste of ants. The only way that he could explain it that did not become a serious threat that might destroy his whole theory of natural selection. So he made a big point of it in The Origin of Species. Then, in The Descent of Man, Darwin turned to humans and said the same thing is happening in humans. He described clearly group selection. What happens is that traits that are under the control of genetic prescription in interaction among individuals from particularly forms of communication are but also all other forms of interaction between the due of social nature are favored or disfavored by the natural selection caused by competition of group against group. So, this brings us then to the distinction that we are now approaching. It's called multi-level. And it's individual selection, like the birds, occurs when individuals compete with members of the same group on the basis of these traits. Group selection of genetic traits occurs when groups compete with other groups on the basis of interactions of social individuals within each group. Overall, individual selection within groups engenders selfish behavior, allow me to call it sin, and group selection engenders cooperative behavior. How did it come that human beings began to engage in group selection that led to advanced social behavior? We have a pretty good idea from work by cognitive and social psychologists during the last 10 to 20 years. And it is the observation that human beings have two powerful, clearly instinctual traits that are so prevalent and so strong and universal that we never or rarely think of them as human traits. We just think of them as being there like air and water, part of nature. The first one is our intense need to form groups, and we form them easily. Sometimes arbitrarily, sometimes around a common cause, a team sport. It can be based on anything. It can be kin groups, but more likely it is groups of common interest and common geographic origin. And these groups then form, and they are, as social psychologists have shown in experiments, even when they are arbitrarily formed, that is, selection, are made of teams of volunteers to belong to a group and compete games, simple games, with other randomly selected individuals among volunteers. In short order, each group thinks of itself, its members, as being smarter and more trustworthy. And this is a powerful instinct that we have to do that and to live by our groups and to identify ourselves by the groups. And the second powerful influence that we have is to constantly evaluate one another. Human beings are obsessively interested in other human beings. They spend all of their time, a very large part of their time, thinking about individuals that they know, and as the psychologists call it, reading intention. The ability to read intention is developed so much in human beings that we are geniuses at it. And as a result, we can create the social networks within groups that give us the largest chance of success and survival. But it also generates, while we're doing it, so many of the human traits that form in endless permutation the subject matter of fiction and other literature. And that is all that we can do, all that we intensely desire to do to form bonds, to form groups, to cooperate. And that was the key, to cooperate in conflict with other groups. And internally, to engage in affection, in bonds, and as well as to deceive, manipulate, control. That's what so much of human social activity consists of, and we are obsessed with doing it. Those two are the keys that come from group selection, but they also include what we call the basic virtues and the willingness to be altruistic and self-sacrificing. Those of you who followed recent literature and evolutionary theory may recognize that this account of the driving force of the origin of human sociality and other sociality, all the other cases I mentioned, is at variance with the traditional theory of the evolution of altruistic behavior and eusociality by kin selection and its supposed product, the measure of inclusive fitness. 2 years ago, two mathematicians of the first rank, Martin Novak and Karina Tarnita at Harvard, and I showed that the basic assumptions of the inclusive fitness theory are mathematically unsound, and second, that the biological explanations that have been derived from it to try to explain it by kin selection are easily and probably better explained by multi-level selection of the kind I've just given you. Individual level selection and group selection or the combination thereof. Kin selection suggested or posited that it is groups of kin that come together that become altruistic because they can be altruistic and not lose their own genes, prescribing their own behavior. Because if they are with a close relative, a brother, I'm talking about collateral relatives now, not offspring, the universal Darwinian individual level selection. If they're collateral relatives, brother, sister, cousins, nephew, niece, and so on, then if they sacrifice some of their longevity, they sacrifice some of their security and wealth to support altruistically these close relatives, then you can have a group forming and it can grow by this kind of behavior and the spread of the genes that promote it into an advanced social group. Unfortunately, that is mathematically incorrect. And the mathematical argument after 18 months caused, how shall the British call it, a fluttering of the dovecote, considerable blowback for those who were working in that field and using that theory. Nonetheless, after 18 months, there has been none have addressed the mathematical argument. There's no objection to it. And second, no critique that I've seen of the alternative explanations by multi-level selection and particularly group selection that would propose as alternative to those explanations that have been provided by kin selection. So I've covered this subject in considerable depth in the book, The Social Conquest of Earth. And if interested, you can pursue the subject there. And I felt that I needed to give you a caveat that in terms of opinion, this is not settled. But with the fact that quite a few refuse to accept an alternative to kin selection theory means nothing, because the science is not conducted by polls. And moreover, we have a substantial group of scholars and other mathematical and evolutionary theorists who are convinced that our approach is probably the correct one. In any case, if we are right, and we are right, the door is now fully open for a fuller examination of the biological origins of human nature. The applications of kin selection were very narrow in the scope that they could make any explanations of sound convincing. I'm going now to move quickly to a close just by mentioning in passing other human instincts may or may not be subject to this type of social multi-level selection, but nonetheless should persuade us a bit more than we have been persuaded, generally, even the academic community, that we do have irrational behaviors that are the residue of that long prehistory that brought us to where we are today. And also to persuade you that history can explain a lot, but it is sharply truncated and stops at the birth of literacy, and that we have to go on back and back to understand the origins of the human condition, that history makes no sense without prehistory, and prehistory makes no sense without biology, and it is here in the relation between biology and history itself that will be one of the junctures, symbiotic relation between disciplines in two of the great branches of learning. First, I'll just mention that one of the consequences of this connection of the conflict between group selection and individual level selection is that it is unstable. We are a conflicted species, and we will be a conflicted species forever, because we cannot go to either extreme, all the way to individual level selection. That would dissolve the society, not all the way to group selection. That would make us angelic robots. We're going to be caught, suspended in the middle, and this is a good explanation, as we have, of why human beings are so fundamentally conflicted, and particularly just within their own families, but in their own group, and also internationally. And that may be if all of the cases of known eusociality and all these very different groups of organisms, and we never really gave serious thought to this before, but if all of them were created the same way, and they appear certainly to have been created the same way, follow the same track through the maze, then it may well be possible that this is the only way that you can reach a human level of intelligence and social organization. And if that is true, that is a very fundamental constraint on the way social behavior and advanced organization and intelligence can be developed anywhere. So maybe that's the only way that it's ever occurred, if it has through the rest of the universe. Just a thought. Now for the, I'm going to pass on to the origins of intelligence and culture. I cover them in the book, but I don't have time to go into them now. But I just wanted to show you a couple of amazing things that people don't realize about themselves that are a result of their sensory apparatus, the constraints on their sensory apparatus, and they tend to be irrational. I mean, they're beyond conscious control. Of these three designs, the ones that arouse you the most, that's the one in the center. I guarantee you that that's the case. You can see the impact, on the brain, on arousal, the damping of the alpha waves. And this is quite possibly behind a lot of culture. Namely, for example, in the level of complexity and design of pictographs, it's shown in this Japanese example, the beautiful Punjabi text, the levels of complexity commonly seen in so-called primitive art. Even in modern design, as for example in this magazine or journal cover some time ago, the artist has chosen to represent the brain at that level of complexity. And down at the lower left-hand corner, you will see the logograph of the American Academy of Arts and Sciences has that level. Now we come to the preferred habitat. Many of you may have heard of this, that cross-cultural tests have shown that when people can choose any habitation, location where they can live, they have their habitation, and thus they have a view out. They choose three features. They want to be on a rise. They want to look out over a park, reed, savanna, and they want a body of water next to it. And that's what they will pay extremely high prices to get, regardless of whether there's any utilitarian value to it. It's instinctive. And it's not too much to say for reasons that I could argue but don't have time now, that it's a residual habitat preference that all animals display and that is necessary for their survival. And I will conclude with this, and I'm going to leave it at this as you read this, as to where we go from here. I'm going to be a little bit strong-worded about the 4 decades that we have labored and spun our wheels with Ken selection theory, and I'm guilty of that too, because in my first books in sociobiology, I adopted it as a good genetic explanation. And those words are that we now have got to clear the wreckage of kin selection off the road so we can move ahead. And now that that's being done, what I've now written here will be much more likely to come to pass. Whether I've actually made any progress toward answering Paul Gauguin's 3 great questions, whether or not this is likely to be the direction we're going to take in this era, this domain of evolutionary theory, I lead to your good offices, you future scientists, and to the development of history. And I thank you for listening to me tonight.